Hey guys, and welcome back to my channel. This is Trusty Rusty Depot, and today we're going over one of the most important Rust topics, which is borrowing and references. So let's dive right into it. So if you remember from the last video, we left off where we had this code and it wasn't working. So what we did is we have this function called calculateLength, which takes in a string and it returns the length of that string, so a U size. What we do in our main is we create a string called string1 and we make it equal to hello. And we create a variable called length and we call the function with string1. And then we try to print string1 again afterwards, which doesn't compile because our function takes ownership of our string. So when we try to use it again, it's already moved and dropped after this scope is ended. If you need a refresher on that, you should go back and look at my last video. So there are two ways we could fix this. One way we could fix this is we could just return the length as well as our string again. That way we could use it. So in our function, we can return a tuple of usize and then string. And here we return a tuple of usize and then string. And then up here, we need to change our code to take in our string variable as well from this function. And then we can use our string variable here. And this compiles. If we try to compile this, we can see that we get hello. So this works, but it takes a lot of work to take this tuple and return it. And we can do something much simpler. So instead of using a tuple, what we can do is we can use something called a reference. Now, a reference is a pointer to our value. And what's special about a reference is that it can access the value without taking ownership. So in order to do that, we need this function to take in a reference to the string instead of the string itself. So we can add an ampersand in front, and right here when we call the function, add an ampersand as well. And now we can see the code compiles and we get hello. So the ampersand allows us to reference the value without taking ownership. And we can also dereference the value with an asterisk, but we'll go over that later. So what happens in our function is this string gets used, and at the end of the scope, it gets dropped. But since it's a reference and not the actual value itself, nothing happens to our original string1, and we can still use it afterwards. Now, let's say instead of just taking the string and returning the length, we want to change it. We want to add the word world into it. So we can say change string. We take and string as before, and we say string.push string world. And we remove the returning value. And we change the call up here. Now, if we try to run this, this doesn't compile because as the function is only getting a reference, it can't be changed. It can't change the reference as it's an immutable reference. So how we fix this is we can change this reference to a mutable reference. Say and mute string. So here we change it to a mutable reference. And here we also have to change this mute. And now this code compiles. However, there is one big restriction with mutable references. If we try to take multiple mutable references and then we try to print them, and we try to compile this, this doesn't work because we have used 2 mutable borrows. And that is the big limitation with mutable borrows, is you can't have multiple mutable borrows. This protection is in place because otherwise we could have data races where 2 different pieces of code are trying to mutate the same value at the same time, and some other piece is trying to view the value. So because of that, we also can't have a immutable reference at the same time as a mutable one. So if one of these were a mutable reference, this wouldn't compile because we have a mutable and immutable borrow. And this protection is in place because the immutable borrow doesn't expect the value to change while it's being read. Similarly, there's another error that can happen with references called Dangling References. So if we have a function called dangle, and it returns a string, and then inside we have a string, and then an empty string, and then we return a reference to the string, and then we try to call this in main, there's a problem with this because once this function ends, this value gets dropped, which means this reference now points to nothing because this value has been dropped. So if we try to run this, we get an error, and the error tells us it expected a lifetime parameter. So it wants this reference to be able to live longer than its own value. And we'll get into lifetime parameters later. That's what the error is trying to tell us. Something else that's interesting with references is there's actually a special type called the slice, which allows us to reference a specific part of another value. So for example, if we have a string, and we want to create 2 values that are parts of the string, we can do that with a slice. So for example, if we want just the hello part, we can have a reference to string, and then we use brackets to say which parts of it we want. So from 0 to, so ... is the range syntax of Rust, 2, and it starts at 0, so if h is 0, we go 1, 2, 3, 4, so up to 4, but Rust doesn't include the last index, so either we can put an equal sign there to make it an inclusive range, or we can just go up to 5, and then we can go world equals and string 6 to 11. Now, what we can also do is, instead of telling it that we want the 0 index, we can just drop 0, and it'll assume that we want the beginning of the slice. Same thing for the end, so we can drop this, and we can say that we just want all the way to the end. So, if we did another variable and we did ... that would essentially just be the whole string. So that's it for this video. Thank you for watching. For the next video, I want to do a mini project tutorial to sum up what we've learned so far. If you have any ideas or you want me to do a specific mini project, feel free to comment down below your ideas. I'll be looking through to see if anybody has anything interesting. That being said, thank you for watching, and I'll see you in my next video.